Welcome to Biomed for Dummies. While this channel is dedicated to biology, we will be touching on chemistry and physics as all three fields are deeply connected with each other. Given the vast amount of concepts in the field of biology, it may be possible for some areas to be a bit confusing. In the video descriptions, I will recommend sources of literature that might be beneficial. Today's video is on an introduction to biochemistry, so let's get into it. Before we go through all the more complicated bits, let's get our definitions cleared up. Chemistry in essence is the science that deals with the structure of matter, defined as anything that takes up space and has mass. When we look at mass, which is the amount of material in matter, we consider it as a physical property that determines the weight of an object in Earth's gravitational field. Atoms are the basic building blocks of matter that can define specific elements. The smallest stable units of matter are called atoms. Everything that you are seeing right now is made up of atoms in varying compositions. These atoms are comprised of subatomic particles. For this video, we will only look at the three important for understanding the chemical properties of matter, which are protons, neutrons, and electrons. Protons and neutrons are similar in size and mass, but protons, P+, have a positive electrical charge, whereas neutrons, N or N0, are electrically neutral or uncharged. Electrons, E, are much lighter than protons and bear a negative electrical charge. As seen in this two-dimensional representation, the electrons occupy a circular area called the electron shell. An element is a substance with the same number of protons in all of its atoms, also known as the same atomic number. Although an element's atoms must all have the same number of protons, the number of neutrons might vary, resulting in varying masses. Isotopes are atoms of the same element that contain differing quantities of neutrons. Oxygen, as seen in the period table, has an atomic number of 8. For a stable oxygen molecule to exist, two atoms must bind to each other. If, however, this oxygen molecule had bound to a different element such as hydrogen, then it would be called a compound. Because atomic nuclei are unaltered by ordinary chemical processes, elements cannot be changed or broken down into simpler substances in chemical reactions. Thus, an atom of carbon always remains as an atom of carbon, regardless of the chemical events in which it may take part of. The mass of a large object, such as yourself, is the sum of all the masses of all the component atoms. Therefore, the mass of the atom is determined primarily by the number of protons and neutrons in the nucleus. Mass of atom equals number of protons plus number of neutrons. Normally, atoms would contain equal numbers of protons and electrons, meaning the number of electrons would equal the number of protons. The number of protons in an atom is known as its atomic number. The number of neutrons is equal to the difference between the mass number of the atom, m, and the atomic number, z. Let's take hydrogen as an example. It is the simplest atom with an atomic number 1. Following the rules that we just discussed, this would mean that the hydrogen atom contains 1 electron and 1 proton. The hydrogen's proton is located in the center and forms a nucleus. All atoms other than hydrogen have both neutrons and protons in their nuclei. Remember we talked about the definition of isotopes earlier? Taking hydrogen as an example again, we have different isotopes. The first one is hydrogen 1, with 1 proton and 1 electron. The second one being hydrogen 2, also known as deuterium, with 1 proton, 1 electron and 1 neutron. The third one is hydrogen 3, also known as tritium, with 1 proton, 1 electron, and 2 neutrons. Alright, let's do a recap of what we learnt. We went through the definitions of the following chemistry: matter, mass, atoms. We looked at the subatomic particles like protons, electrons, and newtons and how they are positioned in the electron cloud. We looked at equations that can be used to determine the atomic mass and atomic number, also talked about elements and compounds and also about isotopes and radioisotopes. In the next video we will be talking about chemical bonds and the forces formed by atomic interactions. So don't forget to subscribe and hit the like icon. Until I see you in the next video, stay safe.